Hi everyone, so today I'll be going through the Networks and Decision Mathematics section of the 2018 Further Maths Exam 1. So question 1, consider the graph with 5 isolated vertices shown below. To form a tree, the minimum number of edges that must be added to the graph is. So you should know that the formula for the number of edges in a tree is E equals V minus 1. So if we use this formula, we know that the graph has, that there's 1, 2, 3, 4, 5 vertices. So 5 minus 1, so the number of edges would equal 5 minus 1, which is 4. So therefore, the minimum number of edges in order for the graph to be a tree is 4 edges. So B is the correct answer. Question 2. Nico drives from his home to university. The network below shows the distance in kilometers along a series of streets connecting Nico's home to the university. The vertices A, B, C, D, and E represent the intersection of these streets. The shortest path for Nico from his home to the university could be found using. So you should know that we have option A, which is minimum cut. A minimum cut does not find the shortest path from one place to another. A minimum cut is used to find the maximum capacity through a network, or through a graph. So therefore, that wouldn't be the right answer because it doesn't find the shortest path. Prim's algorithm is used to find the minimum spanning tree. So therefore that's wrong. You should also know that Dijkstra's algorithm is used to find the shortest path. So therefore C would be the correct answer. I'll go through the other ones. So option D, critical path analysis, is used to find the shortest time in order to complete a project. And the Hungarian algorithm would be used to allocate people with the shortest time to complete the task. So therefore C is the correct answer. Question 3, a planar graph has 5 faces. This graph could have, so you should know that the Euler's formula is V minus E equals 2 minus F. So V is the number of vertices, E is the number of edges, and F is the number of faces. So in this question, we know that the planar graph has 5 faces. So therefore, number of vertices minus the number of edges equals 2 minus the number of faces, which is 5. So therefore, we know that V minus E equals -3. So that'd be our rule. So we need to determine which option is correct. So the number of vertices minus the number of edges should be -3. So let's try option A, V minus E. So A minus 8 equals 0. That doesn't equal -3. So therefore that's wrong. V minus E. So 6 vertices minus 8 edges equals -2. That doesn't equal -3. So therefore that's wrong. 8 vertices minus 5 edges equals 3. So that's wrong. 8 vertices minus 6 edges equals 2. That doesn't equal -3, so that's wrong. 5 vertices minus 8 edges equals -3. So therefore, E is the correct answer as it follows the rule we have found. Question 4. Consider the graph below. Which one of the following is not a path for this graph? So you should know that a path has no repeated edges or no repeated vertices. So if there are repeated edges or vertices, then that means it would not be a path. So let's try option A. P to R to Q to T to S. Therefore, no repeated edges or vertices. So that is a path. Let's try option B. So P, Q, R, T, S. No repeated edges or vertices as well. So that is also a path. Let's try C. P, R, T, S, and Q. No repeated edges or vertices in that path either. So therefore it's a path. D, P, T, Q, S, R. That's not actually possible to get to R. So therefore D would not be a path for this graph. So therefore D is the correct answer. Question 5. The directed network below shows a sequence of 11 activities that are needed to complete a project. The time in weeks that it takes to complete each activity is also shown. How many of these activities could be delayed without affecting the minimum completion time of the project? So the first step is to complete the critical path analysis, which I've just done to save time. And we want to find the number of activities that could be delayed without affecting the minimum completion time. So these would be activities that have that are not on the critical path. So activities that have that do not have a slack time of 0. So for example, we can see that C over here has a slack time of 5 because it's the latest start time minus the early start time, which is 0. So it does not have a slack time of 0 and it's not on the critical path. So therefore it can be delayed without affecting the minimum completion time. Same as G, which does not have a slack time of 0, has a slack time of 5. And we can also see that E has a slack time of 4. 8 minus 4 is 4. And I also has a slack time of 3. And there are no other activities that do not have, other than these, that have a slack time greater than 0. So therefore the number of activities that could be delayed without affecting the minimum completion time of the project is 4 activities, which we have found. So therefore B is the correct answer. Question 6, which one of the following graphs is not a planar graph? So you should know the definition of a planar means that a graph that can be drawn so none of the edges meet or cross over each other. So for example, we look at option A, we can see that we can actually redraw this graph so that none of the lines cross over to be like that. So therefore that would be a planar graph. So we obviously know that E is a planar graph, so we took that off. Let's take a look at C. We know that C is planar because if we get rid of these 2 lines and draw them across like that, the graph has no lines that cross over each other. So C is also planar. For option B, if we move these edges, if we get rid of these edges, if we replace these edges with a vertex over here, and therefore we know that that's connected. That's connected. And that is also connected. And therefore we could now redraw this part over here to be like that. And therefore, as you can see, the graph is now planar. And if you also check the sum of the degrees of the vertices, you can also tell that this graph has 6. The sum of the degrees of the vertices of this graph is 16, which was the same as the original one we had, which therefore suggests it's also the same graph, despite looking drastically different. So that leaves us with D, and D is therefore not planar. I've tried to do D and I could not make it planar, so therefore D is the graph that is not planar. Question 7, a project requires 9 activities A to I to be completed. The duration in hours and the immediate predecessors of each activity are shown in the table below. The minimum completion time for this project in hours is. So to do this question, you have to draw a network from this table given over here. So I've basically done that for you, and now we need to find the minimum completion time for this project. So we start off with 0, 4, and just to let you know, when we're doing the forward scan, you always pick the largest number. So 4 plus 3 is 7, 4 plus 7 is 11, 4 plus 2 is 6, which I've done, 6 plus 5 is 11, 11 plus 2 is 13, 7 plus 5 is 12, pick the biggest number, 13, 13 plus 4 is 17, largest number is 17, 17 plus 3 is 20, so therefore the minimum completion time of the project is 20, therefore C is the correct answer. Annie, Buddhi, Chuck, and Dorothy work in a factory. Today, each worker will complete one of the 4 tasks, 1, 2, 3, and 4. The usual completion times for Annie, Chuck, and Dorothy are shown in the table below. Buddhi takes 3 minutes for task 3. He takes K minutes for each other task. Today, the factory supervisor allocates the task as follows. Task 1 to Dorothy, Task 2 to Annie, Task 3 to Buddhi, Task 4 to Chuck. This allocation will achieve the minimum total completion time if the value of K is at least. So we obviously know that can't take someone 0 minutes to complete a task, so therefore we just straight away take out A as our option. And we want to find the minimum value of K. So let's start off with, so we want to find the least value of K. So the allocation is a minimum. So this allocation given in the question is a minimum. So let's start off with the largest number 4. So if we make K 4, will this still achieve the minimum total completion time? So we know task 1 goes to Dorothy, task 2 to Annie, task 3 to Buddhi, task 4 to Chuck. So let's just look. So initially, let's just look for the smallest. The smallest number should be in each column. That's currently the allocation. So 4 for Dorothy is the same as 4 for Buddhi, so that wouldn't make a difference in the completion time. For task 2, there is a difference of 1. However, Buddhi has already completed task 3, so you wouldn't really move it down. Because if you did move this to 4, then you would have to increase the task 3 duration by a minimum of 2 minutes, which is not worth it. So you just keep it at 3. And task 3 obviously goes to Buddhi. Task 4, 2 is the smallest in that column. So therefore, the minimum completion time will still be achieved with if the value of K is 4. Let's try 3 now. Try 3. If we try 3, task 1 could potentially task 1 could potentially move to Buddhi, and task 2 would move, but it's not worth moving task 1 to Buddhi because task 4 would have to increase by a minimum of 2 minutes because the next a minimum of 3 minutes because the next smallest time but for task 2 is 6 minutes, so that's an increase of 3 minutes. It's not worth the move, so we'll just keep it how it is. So 3, and then let's look at task 3, the column for task 3, there's only Buddhi's doing it. Task 4, still the 2 circled is smaller, so therefore that would not affect the minimum completion time of the project. Now we can try the value of K as 2. So if we move, so this could potentially move here, and task 2 could be allocated to Chuck, but that's not guaranteed yet. Or we could leave task 2 how it is. We could leave task 2 allocated to Annie. So let's just circle this, and so that 4 we would minus 2 from the duration. Currently, the minimum duration could be reduced by 2. The current minimum duration could be reduced by 2 so far. And we could move, so 3 would stay the same. And task 3 would have to be allocated to someone other than Buddhi. So that could be allocated to task number 5, but that would so therefore we're back to our original completion time if that would occur. So therefore task 2 wouldn't make a massive difference. So therefore task 2 will still achieve the minimum completion time. It has not affected the overall completion time of the project. So let's try 1. and basically 1 is our leftover option. Even if you try 1 in the equation, in the value of k, the minimum completion time of the project will be reduced. We can even try that. So k is 1. Therefore, currently the time taken to complete the project is 4 plus 3, so 7, 10, 12 minutes so far. So if we try 1, it could be, we could obviously move task 1 to Buddhi. Task 2 could remain at Annie. Task 3 could be moved to Dorothy. And task 4 could be moved to Chuck. That would give us a overall completion time of 11, which is less than the original minimum completion time. That give us 11, this new allocation. So therefore, the allocation will achieve minimum completion time if k is at least 2. Because if we sub 1 in, we know that the minimum completion time has changed. So therefore 2 is the minimum completion time for the project. The value of k, if the value of k is 2, then this will retain the current minimum completion time of the project. However, if we move to 1, it decreases the minimum completion time of the project, and we want to find the least value of k, where the minimum completion time stays the same as the allocation given above over here in this question. So therefore C is the correct answer.